Pollination is essential for meeting our daily needs. Fruits like apples, watermelons, and blueberries all require pollination. However, since 1962, the US has lost 90% of bee colonies. Millions of bees have died because of colony collapse disorder, and this has threatened the agriculture industry and the environment. The world is threatened by an unparalleled challenge of food insecurity, and we need to find a solution soon to solve this impending problem.
To address this challenge, we've designed BeeBot, an aerial drone capable of vertical pollination that is projected to increase crop yields more than 25 to 50%. To create a successful pollen dispensing drone, multiple mechanical aspects had to be considered, tested, and precisely designed. In order to carry and release the pollen contained in the dispenser, a square funnel with 4 dividers will be utilized, with the goal of keeping 4 pollen types separate and available to be dispensed from the bottom of the funnel. The bottom of the funnel itself contains a cylindrical component combined with a gear that spins along an axle. This part will take the shape of a 3/4 circle, which will allow only one section of the dispenser to be exposed to the outside world and be released. The closed-off sections will not be allowed out, and their pollen will be safely stored while the drone flies around. The fan, which as we said sits on top of the funnel, will be used to create airflow between the pollen particles, as well as to encourage the downward movement of the pollen out of the exit hole. The servo motor works to close the entire opening of the funnel, keeping all pollen grains intact before the drone lifts off and gets into position, as well as when its automated path ends. The motor shown here is a stepper motor, which, using its gear, will be able to open one pollen exit hole at a time by rotating the gear attached to the cylinder by increments of 90 or 180 degrees. Lastly, in order to contain the whole dispenser system, it's housed in a case that holds all the components. It both protects and organizes the motors, dispenser, and fan systems. It allows the dispenser to function in the many possible environments BeeBot will be used in.
We produced a simulation using CFD software to model the gas flow throughout the fan. The post-process results show that the pressure on the fan was constant without any weak points, and the velocity magnitude of the airflow was very low, which is exactly what we were looking for.
BeeBot's user-friendly app interface will feature essential capabilities, such as real-time monitoring, customizable waypoints, advanced drone logistics, and support for multiple drones. The app will be designed using Python, ensuring its ease of use, and provide unparalleled functionality for controlling and managing the drones. With this interface, we can easily keep track of the remaining flight time for our drone. The current location of the drone is also clearly displayed for our convenience. Utilizing the sliders provided, we have the ability to limit the altitude and manage battery consumption. Next, the user is prompted to input the location of the agricultural field that needs pollination. The drone map displays the agricultural field that has been previously inputted and allows you to set the waypoints of the area that needs pollination. The software automatically grids the waypoints for the drone's flight path, and if multiple drones are being deployed, the interface allows for real-time monitoring of all the drone statuses using swarm algorithms. The current tab gives you an overview of important details such as temperature, the altitude and speed, and estimated time. The route tab allows you to adjust various settings such as speed and altitude.